Hey, welcome back to your favorite trigonometry class. We're going to take a look at law of cosines. Here's our objectives today, as well as we'll solve two situations, two cases for side angle side and for side side side. So case 3 and case 4, as we mentioned for the law of sines lesson. Here is the law of cosines, and I'd like to do the proof so you can see where those come from. Here's the proof. We've got a triangle. Let's go ahead and label this angles A, B, C. So this is side C. We got A, we got B, and height of the triangle. Let me draw my altitude there. I'm going to call H. Okay. And so what I have, number one, let me start out by right triangle trig. I have the sine of angle A is opposite side, so that H side over the hypotenuse B, if I'm looking at that left-hand right triangle, right? So in other words, if I was to solve for H, so by multiplying B on both sides, H would be B sine of A. The second step I'm going to do, similarly, the cosine of A, which is adjacent over hypotenuse, and let me label this x, the adjacent side. So then over here, since this whole thing is c, this part here is c minus x. That's c minus x on that side. So anyways, cosine of A would be the adjacent side, x, over the hypotenuse b. And if I was to solve that for x, by multiplying by b on both sides, x would be b cosine of A. Now what I'm going to do here is I'm going to use the Pythagorean theorem with this triangle right here, this right triangle, okay? So by Pythagorean theorem, h squared plus c minus x squared equals a squared. And then by substitution from steps 1 and 2, by substitution, I know h is b sine of A. So b sine of A is squared plus, and then I have c minus, and I'm going to replace the x. C minus, so I'm going to replace the x with b cosine A, because I know x is equivalent to b cosine of A. That's all squared equals a squared. I just got to work this out. So I got b squared sine squared A, plus I got two of these c minus b cosine A, so I'm going to FOIL that. So I got c squared minus 2cb, or 2bc cosine of A's, plus b squared cosine squared A. That's again if I FOIL that thing. Okay. Now notice this term, they both have a b squared I can take out, and I'm left with sine squared plus cosine squared. And we know that by the Pythagorean identity, that's 1. So that's 1. So I got b squared times 1 plus c squared minus 2bc cosine of A equals a squared. In other words, a squared equals b squared plus c squared minus 2bc cosine of A. There's your law of sines. Whoops. All right, there's one of them. And similarly, you could do that for those others there. Okay? So law of cosines, law of cosines. All right, let's do this first example here. I do like my blue. Gotta get back to my blue here. We've got a labeled triangle already. That's kind of nice for us. We have A equals 4, B equals 5. Angle C is 50 degrees. And what we're going to do first is we got to decide which of the law of cosines I'm going to use. Now, for that problem that we had, we were given lowercase a, lowercase b, so we had a, b, and angle C. So which am I going to pick, 1, 2, or 3? Well, since I have angle C and I have lowercase a, lowercase b, all these variables are taken care of. So that means I got to use this first equation because that's the only one that has a lowercase c that I can solve for. In other words, if I pick any of the other ones, I'm going to have more than one variable to solve for, and it's not going to work. So I got to use this one. So I got to have 3 of the 4 variables when I pick it. Right. So look at what your givens are and choose wisely, if you will. Now, the other thing you want to keep in mind, especially when you're doing side, is you want to solve for the largest angle first, if possible. In this case, it's not possible because I have an angle given, but if possible, do that. We'll talk more about that as we go on. But here we go. Let's start out here. We have c squared equals a squared plus b squared minus 2ab cosine c. So c squared, our a is 4, our b is 5. Our C is 50 degrees, our angle C. So this ends up being, let's see, 16 plus 25, 40 cosine 50 degrees. I'm going to punch this in, so I got 41. Oops, that's 41 minus 25.7. By the way, when I'm using my calculator, so you don't have rounding error, just use the answer key, right? Don't cut it off till the very end. So just don't round it till the very end. You can round it when you're writing it out, but when you're punching it into your calculator, make sure you're using the entire solution there. This ends up being, let's see, well, I'll give you the whole thing, then we'll approximate 3.910050589, and this keeps going. So approximately 3.91. Okay, so we got the third side. Now what I want to do is, so this is 3.91. Now, what's the largest angle? Well, the largest side is 5, so I'm going to go ahead and solve for angle B here. So I'm going to use the one of the 3 that has a capital B in it. So now I'm going to use the second one, b squared equals a squared plus c squared minus 2ac cosine B. And by the way, if you notice, you may have noticed this already in the patterns. If you have the solo term here, it's the angle over there. It's the angle of it. So lowercase a is the angle a over there, right? You see the b's and the c's are right there next to it. So anyways, so we're going to use this second one, b squared equals a squared plus c squared, so on. Okay. A squared plus c squared minus 2ac cosine b. Is we're going to solve for the largest angle. And by the way, the reason you want to use the law of cosines, find the largest angle as soon as you can, is so that we know if it's acute or obtuse, and then we can just use the law of sines from there after we found the largest angle. Because if you remember, with the law of sines, there's a possibility where the sine of an angle is a positive value. It could have been acute or obtuse, depending, and we had to figure that out, right, situationally speaking. Anyway, so all right, let's keep going here. We got 5 squared equals 4 squared plus 3.91 squared. Anyways, that thing keep going. Minus 2 times 4 times 3.91 cosine of B. I'm going to square these, take it to the other side, so subtract that number. And so you got negative 6.288491, negative 31.2804 cosine B. Now I'm going to divide by negative 31.2804. So let me come up here. Cosine of B equals negative over negative, go to positive. Let's see, that's 0.201036. And now I'm going to run, so angle B is the arc cosine of that, 0.201036. So angle B is 78.4 degrees. So we actually see that it's an acute angle. Notice the cosine is a positive value. If the cosine is positive, right, then we know it's got to be an acute angle. You know, the cosine is 0.201, right? If the cosine is negative, that's the nice thing, is it'll tell us, you know, like let's say it's negative 0.201, whatever. We would then know it's an obtuse angle, right? Because it's in quadrant 2. So that's the nice thing about the law of cosines, and finding the largest angle as soon as you can. All right. Thirdly, now that we know angle C, angle B, we can find angle A. So angle A plus 78.4 degrees plus angle C, 50 degrees equals 180 degrees. So angle A ends up being 51.6 degrees. All right. Again, just to reemphasize, find the largest angle first. It's preferable, then you know if it's obtuse or acute. Okay. All right, let's go with this one here. Notice angle C is my largest angle here. I don't know if it's obtuse or acute, but let me go ahead and draw that. Maybe it's obtuse. I'll write it this way. So again, use find the largest angle, so we know if it's acute or obtuse. After that, you're welcome. Once you know the largest angle, right? Again, there's the biggest side, so I'm going to find the largest angle. And once I do that, I know if it's obtuse or acute, and if I want to, I can just use law of sines after that. It might be easier. So we got 7 squared equals 5 squared plus 4 squared minus 2 times 5 times 4 cosine of angle C. So we got, let me subtract, I'm going to sum those and subtract that number. Say 49 minus 25 minus 16, we got 8 equals negative 40. Cosine C divided by negative 40 divided by negative 40. Oops, negative 40. So bring that up here. Cosine of C is negative 0.2. So we know if the cosine's negative 0.2, then that angle's got to be obtuse, right? So we run the arc cosine. Make sure you're again in degrees. Come on. And angle C ends up being 101.537 degrees. 101.537. And like I say, after that, you're welcome to use the law of cosines. As long as you know the largest angle in that triangle, you can use the law of sines. I'm sorry, law of sines is what I meant to say after that. So I have lowercase c, I have uppercase c. I'm going to find, how about angle A? I have A. I'm going to find angle A. So we got 7 over sine 101.537 degrees equals my A over sine A. So we got 7 sine of A equals 5 times the sine of 101.537 degrees divided by 7 divided by 7. So angle A, once I take the arc sine of that stuff, angle A ends up being 44.415 degrees. So lastly, angle B, so now we have angle C, 101.537. I have angle A. Solve for the remaining angle B because they all add up to 180 degrees, and you get 34.048 degrees. Okay. All right, let's work this problem here. We got a motorized sailboat leaves Naples, Florida, bound for Key West, 150 miles away, maintaining a constant speed of 15 miles per hour. But encountering heavy crosswinds, strong currents, crew finds after 4 hours that the sailboat is off course by 20 degrees. We're going to need a diagram here, so let me kind of do my best to draw this. I've got a very pitiful Florida here. Here's Florida. I got Naples right here. Here's, oops, come on, draw nothing. Come on, draw, Naples. And to Key West, here's Key, oh, come on. Here's Key West. We know it's 150 miles. Okay. Let me draw this here. This is C. We call this angle B. And the problem is this thing got blown off wind. They drove for 4 hours, but they got blown off wind. So normally, yeah, it's 150 miles. They got blown off course this direction by 20 degrees. So we know angle C is 20 degrees. Okay. And so, how far is the sailboat from Key West at this time? So we want to know little c for part A. So what's little c? How far off are we? And by the way, number one, we did go in that direction, the off-course direction, for 4 hours at 15 miles per hour. So 4 hours, 15 miles per hour. So we got 60 miles is how far they went right here. So that's our B, is 60 miles. So they went 60 miles in the wrong, a little bit in the wrong direction. Okay. Again, we're looking for lowercase c, and I'm going to say, well, I have lowercase a, I have lowercase b, I have capital C. So what I'm going to do, number one, is I'm going to use the appropriate law of cosines. So c squared equals a squared plus b squared minus 2ab cosine capital C. And my lowercase c I don't know, but I do know that's 150. Do know that's 60. So minus 2 times 150. That's a 150. 60 and cosine 20 degrees. Once I do all that and I square root that, that'll end up being 95.84118544 miles. So approximately 95.84 miles. Okay, that's our C. 95.84. So that's how far, that's part A. How far is the sailboat from Key West at this time, right? They drove 60 miles, a little bit off course. Now they got to go 95.84 miles. B, through what angle should the sailboat turn to correct its course? So what we want to know is, what's our angle right here? What's angle A? So step 2, what's angle A? So I'm going to use this one. A squared, equals B squared plus C squared minus 2BC cosine A to find angle A, which is our largest angle. So because the lowercase a is our longest side, so the opposite angle that creates that, it's got to be the largest angle. So I want to use law of cosines when I'm doing that, right? So use law of cosines there, not the law of sines. You'll end up with an acute angle for the law of sines. You'll be wrong on that. So 150 squared equals, my B is 60 squared, 95.84 squared minus 2 times 60 times 95.84 cosine A. And then I'm going to add, square those, subtract on both sides, that number, and then I'm going to divide by this number, that number, I call it number 2, and I end up with cosine A when you work that out. And then I take the arc cosine on both sides. So run the arc cosine of both sides here. Angle A then ends up being, make sure you work this out on your own calculator, your own scientific calculator. Make sure you can get that correct. 147.64 degrees, okay? So that's, now we've done that. Now we've done the 147.64 degrees. How much time has been added to the trip because of this? So let me, you know what, let me erase a little bit of this. I don't have any room here. Okay, this was 147.6.64 degrees. That was angle A. All right, how much time has been added to the trip? Well, normally, if we'd have gone straight shot there, right? Distance equals rate times time. We had 150 miles. Our rate was 15 miles per hour times time. So divide both sides by 15 and it would have normally just taken 10 hours, right? But now total distance equals rate times time. The total distance is we went 60 and then we went 95.84. So 60 plus 95.84 is our total miles. We're still going 15 miles per hour. And so we got 155.84 equals 15t divided by 15. So it looks like it's 10.389 hours when we were off course, because we caught it after 4 hours, right? So 10.389 is the total hour. So what's the difference? Well, 10.389 minus 10 is 0.389 hours extra. But let's put it in minutes. So times it by 60 minutes per hour. So 0.389 times 60 equals, sorry, I gotta come over here, 23.34 minutes extra. 23.34 minutes extra. Well, thank you so much for listening, and that's the Law of Cosines. We'll see you guys next time.